Hello everyone, I'm Chloe. Welcome to today's lecture on environmental case studies. We'll explore how data science is applied to critical issues like climate change, pollution, and biodiversity. Through real-world examples, we'll see how data-driven insights can lead to solutions for some of our biggest environmental challenges. Here's what we aim to accomplish today. First, we'll analyze case studies where data science helps address environmental problems. Then, we'll see how predictive models provide valuable insights into climate change, pollution control, and biodiversity conservation. Finally, we'll discuss how data science optimizes resource use in sustainability and the circular economy. Climate change. Data science applications. Climate change is one of the most urgent issues of our time, and data science plays a crucial role in understanding and addressing it. By analyzing historical data on global temperatures and CO2 levels, we can track changes over time and predict future scenarios. The Intergovernmental Panel on Climate Change, IPCC, reports that global temperatures have risen by 1.1 degrees since pre-industrial times, and CO2 levels are now 50% higher than in 1850. This kind of data enables scientists and policymakers to make informed decisions about climate mitigation and adaptation strategies. Case study: analyzing global temperature rise and CO2 emissions. Let's dive into a case study that uses NASA's Global Land-Ocean Temperature Index and CO2 data from Mauna Loa. By analyzing this data, we can track annual global temperature anomalies from 1880 to the present, and compare them to atmospheric CO2 concentrations. The findings are clear. There's a direct correlation between rising CO2 levels and increasing global temperatures. For example, the last decade has been the hottest on record, with 2020 tying 2016 as the warmest year ever recorded.
This kind of analysis gives us concrete evidence of how human activities contribute to climate change, emphasizing the urgency for emissions reduction. Predictive modeling of future climate scenarios. To better understand what lies ahead, we use predictive modeling. By looking at historical data, scientists can create models that forecast future temperatures and CO2 levels under different scenarios. Two primary methods are used here: general circulation models, GCMs, which simulate physical climate processes, and scenario analysis, which explores possible future outcomes based on different emissions pathways. According to the IPCC, if emissions continue at current levels, we could see an additional 1.5 to 2 degrees C increase by 2050, leading to accelerated ice melt, sea level rise, and extreme weather events. These models are critical for planning and adaptation, pollution control, and air quality monitoring. Moving on to pollution, let's talk about how data science helps manage air and water pollution, both of which are major public health issues. According to the World Health Organization, WHO, 99% of the global population breathes air that exceeds air quality guidelines, leading to respiratory and cardiovascular diseases. By using data science, we can track pollution levels, predict high-risk periods, and implement preventive strategies to reduce exposure. If effectively applied, these data-driven solutions could save up to 1 million lives each year. Case study: modeling air pollution in urban areas. In urban areas, air pollution is often a top concern. For instance, let's look at New Delhi, which frequently experiences high pollution levels, particularly during winter. Data science models using sensor data on PM2.5, PM10, NO2, and ozone can predict the air quality index, AQI, and identify high-risk areas. Through regression models and geospatial mapping, we can visualize pollution hotspots and understand seasonal variations. For instance, New Delhi's pollution spikes during winter due to temperature inversions that trap pollutants. Such insights allow policymakers to plan effective interventions, such as limiting industrial activity during high pollution periods. Data-driven solutions for pollution control. Data-driven solutions go beyond just monitoring. They also guide actionable strategies for reducing pollution. For example, predictive models can forecast high pollution days, enabling authorities to issue warnings and take preventive measures. In water pollution control, data science can help identify contamination sources and track high-risk areas. A case study from the U.S. Geological Survey found nitrate runoff hotspots in agricultural regions, leading to stricter regulations on fertilizer use to protect water quality, biodiversity conservation, and data science. Next, let's discuss biodiversity conservation. Over 1 million species are at risk of extinction, primarily due to habitat loss and climate change, according to a 2019 UN Biodiversity Report. Data science is invaluable in monitoring species, assessing extinction risks, and prioritizing conservation efforts. By analyzing species distribution and habitat data, conservationists can identify biodiversity hotspots and focus their efforts where they're most needed. Case study: predicting species extinction risks with machine learning. In this case study, we use machine learning to predict species extinction risks. Data from the Global Biodiversity Information Facility, GBIF, includes variables like habitat range, population trends, and climate resilience, which are fed into a classification model. Using logistic regression and decision trees, we can estimate a species' likelihood of extinction. For example, our model might identify amphibians with small habitat ranges as highly vulnerable. This insight allows conservation organizations to prioritize those species for protection efforts. Analyzing habitat loss. Using satellite data. Satellite data is a powerful tool for monitoring habitat loss, particularly in sensitive ecosystems like the Amazon rainforest. Using Normalized Difference Vegetation Index, NDVI maps, we can track changes in vegetation cover over time. For instance, in the Amazon, we see deforestation rates exceeding 17% over the last 50 years. By analyzing NDVI data, we can identify high deforestation areas and guide reforestation initiatives. This data supports both local and global conservation efforts, informing policies aimed at slowing deforestation. Sustainability and circular economy models. Finally, let's look at how data science supports sustainability and the circular economy. A circular economy aims to reduce waste by reusing materials instead of discarding them. Data science tracks material flows, analyzes life cycle impacts, and identifies opportunities for resource recovery. By optimizing resource use, we not only reduce waste, but also decrease the environmental footprint of products and services. This approach is vital for creating sustainable practices that meet current needs without compromising the future. Case study: optimizing resource use and waste reduction. In this case study, data science is used to improve resource efficiency in waste management. By analyzing waste streams, we can pinpoint opportunities for recycling and resource recovery. For example, data from e-waste facilities shows that certain valuable metals can be recovered and reused, reducing the need for new raw materials. This is a win-win situation. Recycling valuable materials reduces landfill waste, saves costs, and aligns with sustainability goals. These models are integral to achieving global sustainability targets and reducing the environmental impact of waste. To wrap up, let's summarize what we've covered. In the climate change section, we saw how predictive models and CO2 tracking help guide policy decisions. For pollution control, data-driven models help us address air and water quality challenges effectively. Biodiversity conservation uses machine learning to prioritize at-risk species, and the circular economy applies data science to optimize resource use and minimize waste. Together, these examples show how data science is transforming environmental research and action, enabling us to make informed decisions for a more sustainable future. In conclusion, data science plays a pivotal role in understanding and addressing environmental issues. Through case studies in climate change, pollution, biodiversity, and sustainability, We've seen how data-driven insights guide impactful solutions. Now, I'd love to hear any questions you might have. Let's discuss any concepts or case studies that interested you, or feel free to ask about specific applications of data science in environmental science. Put your answer in the comments.